There's no exponent that can affect the
you put a
positive or negative nature of a number. You know?
Yeah, the exponent will never change the number to be positive or negative. We can't. So you're telling you. We can't put any number in here and then all of a sudden make it a negative up front. What happens if I do put a negative exponent in there?
It makes a small number. Yeah.
Well, see, I don't like to think about it makes it a fraction.
Well, put it not put it like 0.015 or 415.
But the reason why I don't like to think about it makes it a fraction because if I do this, that actually makes it into a whole number. So what does negative exponent do? It reciprocates it. That's what the -1 does. It reciprocates it. So sometimes it makes it into a fraction. Sometimes it takes a fraction, makes it into a whole number. Or if I had something like 2/3 to the negative first power, that would be 3/2. So the -1 just reciprocates it. So I wanted to start with that because we didn't have any like that in our assignment, and that's gonna come up a couple times in today's lesson. Today's lesson is all about logarithms. And we're going to be able to look at 2 to the x equals 16, and you guys are going to yell out what? 4, like you already know. I get it. That's why we're using such an easy one to show you logarithms, because I want you to understand why logarithms work, and I want you to get like the basics of it. I'm not asking you to really find what x equals here. I'm asking you to learn to use logarithms. Okay. So logarithms, the definition is a power to which a log, or sorry, let me read it. A logarithm is a power to which a number must be raised to get some other number. The logarithm is how you get the exponent. The logarithm is how you get the exponent. So if I'm asked to solve for an exponent, I am going to use logarithms. And logarithms and exponentials are inverse operations or inverse equations. They undo each other, just like multiplication and division. So here, I'm going to do this just like not the way you would have done it. The first thing that we're going to do is rewrite 16 as a power of 2. You should already know the answer. You've already yelled it out to me. What is it? 2 to the 4. Okay. Now what I'm going to show you is how logarithms work. So logarithms always have a base. And that base is that little number at the bottom. This is an equation. I'm allowed to do whatever I want to this equation as long as I do to both sides. So I'm going to log both sides with a base of 2. So I'm going to have log base 2 of 2 to the x equals, and on the other side I'm going to have log base 2 of 2 to the 4. Now wait. Logs always have a base. No, logs always have a base. And I chose to use base 2 because what is this called when we talk about exponents? What's that thing called? It's called the base, and this is the base of 2. So what I'm doing is I'm using inverse operations to undo a base of 2. I do log base 2. These undo each other, and they cancel. This is stuff you should have done last year. There's a property that says if we have a logarithm to an exponent, we're going to do this property later in class today, but if we have a logarithm to an exponent, that exponent goes in front and multiplies. So when I cancel these out, I get x. So on the other side, if I move the 4 to the front, and I'm going to cancel out log base 2 with a base of 2, what is left over? 4. So log base 2 and base of 2 undo each other. This looks way more complicated than just saying, well, I knew the answer was 4. Yeah, I know, because I gave you a really, really easy one. Okay? So we're learning them on the easy one. Let's do this again. We've got 3 to the x equals 81. So I'm going to rewrite that as 3 to the x equals, now you should already know this answer, 3 to the 4. Right. But I want to show you using logarithms how we can cancel out the bases and just get the exponents. Because that's what logarithms do. They solve for the exponent. They help you get the exponent not written as an exponent. So what log am I going to use to both sides that's going to cancel out a base of 3? I'm going to use log base 3. And I'm going to do it to both sides of the equation, but the only way I can use it is if I do it to both sides. When you guys say logarithms, this would be read as log base 3 of 3 to the x. You say log base 3 of 3. These will cancel out. The x comes around in front and we get x. Here, the log base 3 and the base of 3 cancel out. 4 comes around and we get 4. Okay. Here's another way that we're going to be seeing logarithms, and kind of think about the same thing. We're going to have log base 4. So what I want to do is I'm going to write this with no logarithm. So I'm going to think to myself, log base 4, I need to write 1/16 as a 4 to some exponent. We kind of have to know how we can make 1/16 into 4 to the power of what? -2. If I can rewrite 1/16 as 4 to the -2, now I have bases that will cancel. And this simplifies to -2. So just simplifying, we can use that concept to do as well. Can you try that one? Yeah. I'll get you started. Log base 7 of 7 to the 0. Because anything to the 0 power is 1. My simplified answer for log base 7 of 1 is 0. Sure. Yours is by the way. Yours is 6.
I think he's coming down bad.
I think it's
Okay, you got nerd. Okay. I'm just joking. I'm gonna give you a dum-dum though. I do have those too. Okay. Alright. Are you okay over there?
Yeah.
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 Okay. Alright, the next question has some very special logarithms that you'll see, and they write them different ways. If it is log and you don't see the base, the base is 10. It's called the common logarithm. If it doesn't show a base, this automatically means that the base is 10. So what I want to think is, what should I make 1 over 100 to? I should make that to a base of 10 to the what? -2. So that my log, which is base 10, cancels out with base 10, and this answer is -10. There's another very commonly used logarithm that they have to make look different. I don't know why, but log base e is never written as log base e. It's written as ln, which stands for the natural log, which is the log of base e. E is a number that you guys learned about in Algebra 2. It's like 2.718, some other stuff. It's an irrational number. So these two, ln and e, are inverses of each other. So I won't write it as log base e other than this first time that you're just learning about it. It's an eyeball. What happens to log base e of base and then of base e? They cancel. What's our answer? Here we go. All right. If you're asked to go from logarithmic to exponential form, or if you're going from exponential form to logarithmic, we're going to treat it like an equation and do things with both sides. So here this says to exponentiate each side of the equation. When I have log base 7, 343 equals 3, this is an equation. There's no variables to solve for. All we're asked to do is rewrite it in a different form. So this is logarithmic form because there's log written in it. We're going to write it in exponential form. So I'm going to exponentiate each side. What I'm going to do is I'm going to exponentiate each side by having a big base of 7. And I'm going to treat this as an exponent now. I'm going to make log base 7 of 343 the entire exponent. Equals. So if I exponentiate one side, yes,
I'm sorry, where did the first 7 come
if I looked at the base, it's always a base of 7.
in?
So I chose to say, I'm going to exponentiate. I'm going to put this as a base and make that the exponent. And as long as I do it to both sides of the equation, I'm going to do whatever I want.
Okay.
So now I'm going to do 7 to the what?
Third.
Third. So we're taking both sides of the equation and making them both exponents.
So that
Because if
7 didn't really come from anywhere, you just went to use it.
I picked it because it's the base.
Okay.
And I picked it because now what happens is these undo each other. And we get 343 equals 7 to the third. And that is true. 343 does equal 7 to the third. Also, the original statement was true. It's just you're not as familiar with logs as you are with exponents. So we just changed the form. That's all we did. Let's do that again with this one. We're going to exponentiate. So the first thing you need to do is what base?
10.
Base of 10. It's not written there, so we know it's base of 10. And then I'm going to take this entire side, log 10,000. And the other side, we're going to have 10 to the 4. So 10 and log base 10 undo each other, and we get 10,000 equals 10 to the 4th, and you should see that go. Oh yeah, that's true. That's true. So the next one, we're going to exponentiate. What should I do to both sides for this one?
It's basically
Right, exponentiate with a base of 3. So I'm going to do 3 to the y equals 3 to the log 3, 5. Then the 3 and the log base 3 undo each other, and we get 3 to the y equals 5. I'm not asked to solve that, I'm just switching them. Oh, did it go somewhere? Wish I knew how to purposely do that. Oops. I know, but I can't, if I want to do it, I can't. I know why. Okay, so now we're going to change from exponential form to logarithmic form. And it says that you're going to log both sides. So if you want to change to logarithmic form, you log both sides. So here, this is 6 to the 0 equals 1. What am I going to log? Log base what? 6. So we're going to do log base 6. And then of 6 to the 0, log base 6 of 6 to the 0 equals, other side, log base 6 of 1. Log base 6 and base of 6 cancel. So we get 0 equals log base 6 of 1. You see how our exponent of 0 is now what the log equals. Logs always equal the exponent. That's what they're used for, to solve for exponents. Yeah.
So why did you do the log base 6 on the other side?
Because if I do it to one side, I have to do it to the other side. That's the rules of solving equations, right? Or just manipulating equations, I should say, so we're not solving. So next one. I want to just change the form to logarithmic form. Which log should I use?
log base 10.
Log base 10, so what do I actually write?
Log.
Log, and we do log of 10 to the negative 3 equals, I have to do it to the other side, log 0.001. So log base 10 and base of 10 cancel. We get negative 3 equals log 0.001. Switched forms, that's all we were doing. How about you try the next one? I'm going to change the form. Okay, is it easy? Is it easy? I don't know what you're saying. What base am I using? Log base 16 of 16 to the 1/4 equals log base 16 of 2. So cancel, we get 1/4 equals log base 16 of 2. Okay, the next is we're just manipulating the logs to simplify them without the use of a calculator. So what I want to do when I'm simplifying logs is I want the log base 5, I want what it is of to have the same base. I want this to say log base 5 of 5 to the, do you know the answer? 30. So my answer is 30. So remember, logarithms are telling you what the exponent is that would give you 125. That's what logarithms do. So the next one. I'm going to rewrite this log. I'm just rewriting it. What is my base? 10. So I'm going to put it in there. Since we're doing notes, you don't need to put it in there. But I need that 1 to say 10 to the something. 0. Right. So the answer to this is 0. A little bit trickier one. So I need this to say log base 32 of 32 to the something. Yeah, it's 1/5. So if you weren't sure about that one, 1/5 is the same thing as the 5th root of 32, and that's how we get 2. So then the answer is just 1/5. You guys are way faster with these answers than my first go. Like, you were right on it with that warm up. You were right on that one. Yeah, it's confirmed. Well, time for us to be tricky. Talk yourself up. No, it's wrong.
It was up here as soon as I came in.
Right, I know. I put it up early. So you had time to think about it? Good. That's why I put it up early. All right, next one. The answer is 1. It is not 0. So when these cancel out, you get what the exponent is, which is 1. So we've got log base 3 of 3 to some power, and that was in your assignment, so hopefully you know that. I couldn't understand. No, it's not 1/4. -4. Remember, the negative exponent is what makes it into the reciprocal. So -4 is the answer to this one. And the next one, log base 2 of 2 to the
Nothing.
So that was that warm up that we were just talking about. You cannot have the log of a negative number. There is no exponent that's going to take 2 and make it into -4. So if you see log of a negative number, that's going to be 1. Yeah.
The way I think of it is like you can't split them.
You're just thinking about it backwards.
Yeah.
It's fine. Just if you ever have the log, if you ever have the log of a negative number, it's not going to work. So that's the second time we talked about that today. There's still another time. All right, now this is like actual real usage of logarithms. The first hump was like just manipulating and getting you used to how to exponentiate logs. Now we'll use them. So you see log base 3 of x minus 3 equals 5. We need to solve this equation for x, but x is like in that logarithm. So you get x out of that logarithm. So what should we do to both sides? To get rid of log. Ooh, that. What's it called? Fancy word. Exponentiate. We're going to exponentiate each side. We're going to put it with a base of 3. I don't know. We never did that last year. Okay, so we got 3 to the log base 3 of x minus 3 equals 3 to the 5. So you have to do it to both sides. Exponentiate both sides. We get those to cancel. And I have x minus 3 equals 2 to the 5th. 3 to the 5th is 243, by the way. So x equals 245. So you can check your answer if you're unsure if you've done it correctly, or sometimes there's, what are they called, extraneous solutions, where you plug it back in and it still doesn't work. We've done extraneous solutions before. This one's not extraneous, but there are some that are. Next one, what should I do to both sides? I'm trying to find the base, so I need that x to not be in that spot. Huh? ln? ln you would use ln if you see an e anywhere. What are we going to use if we see a log base x? Make the base x? Very good. Yeah, we're going to exponentiate with a base of x, so we'll do x to the log base x of 343, because those are going to cancel, equals x to the 3/2. So now I have 343 equals x to the 3/2. So we need to get x by itself. If I had 343 equals x cubed, if I had that, what would you have done? You would cube root. What if I had 343 equals x to the 1/2 power?
You would, let's to this exponent of 2.
I would, yeah, what's that called? Put to the exponent of 2.
Square.
Square, I would square both sides, right?
Yeah.
Right. Yeah, because 1/2 is the same thing as square root, so if I had that, I would square both sides. If I had cubes, I would cube root both sides. We can do that at the same time. We can do both of those at the same time. I'm going to take both sides, and I'm going to raise both sides to a power of 2/3. So I'm squaring and cube rooting at the same time. So I will have x to the, when I multiply these together, I get 6 over 6, that's x to the first, equals 343 to the 2/3. Now that's exactly what you were doing in the assignment yesterday. So 343, does anybody remember earlier what that power? 7 1/3. So if I multiply my exponents, I get 7 squared. So x is 49. Next one. To solve for x, it's part of that logarithm. I need to cancel out the logarithm. What should I do? Split. How many symbols is that though? So we're going to exponentiate both sides. We're going to do 3 to the log base 3 of x times x minus 12 equals 3 to, oh, don't do this. Oh gosh, I forgot. So I probably have some form of this too. When I typed it wrong. Of course I did, and then I forgot this now. This should be a 4 down here. This should be a 3 here. Otherwise, we're going to have horrible answers. You want horrible answers? Nah. Let's get that. So that was good practice, but I'm sorry. I'm sorry. I had already printed them by the time I figured it out. So, what should I do to both sides now? Right, the 4 to that's 3. 4 to the log base 4 of x times x minus 12 equals 4 to the 3rd. That's what we should do. Sorry about that little typo, I already forgot about. Okay, what happens to 4 to the log base 4? Done. And I have, is it okay if I multiply that? Anybody mind if I multiply that out? X squared minus 12x equals, okay if I multiply that out? 64. We just solved for x. How do you solve for x when you have an equation like that? Huh? Subtract 64. So it says equals 0. See if it can factor. What if it can't factor? quadratic formula or complete the square. The original one didn't factor. We had to change it. So I get two answers. It is possible that we might have an extraneous solution. So we need to check our answers. So let's plug 16 back in for x and make sure that doesn't give us any extraneous solutions. I have log base 4 of 16 multiplied by 16 minus 12, 4. Has to equal 3. So I have log base 4 of 64 equals 3. This one works. Because remember what logs do is it gives you the exponent. So 4 to the third is 64. It'll work. The other one, let's check negative 4. Remember we can't have a log of a negative number? So it's very possible that we might have an extraneous solution here. So we need to check it. So we have log base 4 of negative 4 multiplied by negative 16. Multiply those together. Log base 4 of 64 equals 3. So that one works as well.
Wait, why don't you have a negative complete number? I got the whole
So when I multiply these negatives together, I still have log of a positive number. I'm good. So we have two solutions for this one. If one of them was negative, like if I had log base negative 64, you'd have to reject it. It would be extraneous. You can't have log of a negative number. We just have our two solutions. Alright, next one. We got ln of 2x minus 3 equals ln of 11. What's going to cancel out ln? E. And E is a base. So we are going to exponentiate both sides. We're going to exponentiate each side. I'm going to have E to the ln 2x minus 3 is E to the ln 11. Anytime you see E to the ln, they undo each other. And then you solve what's left over. And you check your answer, that one works. We move on to the next one. Make sure that you know that E is a base, so ln goes to the exponent. And what do I do for this one? Subtract 5 first. So now we have E to the x plus 1 equals 15. So E is a base. I need to solve for that exponent. How do I get rid of a base? I'm going to log both sides. And since this is E, what log base what should I use? Well, I'll use log base E, which is ln. Yeah. So we're going to do ln E to the x plus 1 equals ln 15.
Why didn't you put in
Do you answer your question? Okay. So then ln is log base E of E canceled. So we get x plus 1 over here equals ln 15. So I have x equals ln 15 minus 1. Now, I don't know ln 15. That's not one I can do in my head. But this could be a calculator question, so let's find the ln on the calculator. I don't know if you guys ever looked that closely at these, but on your calculator, a lot of these buttons are inverse buttons. Like x squared and square root are the same button. Log and base of 10 to the x are the same button, because they're inverses. And ln and e to the x are the same button, because they're inverses. They undo each other. So to do ln 15 minus 1, you're just literally going to type in ln 15, close your parentheses, subtract 1. And typically we do like
2.
4 decimals. So 1.7081.
Sweet, correct.
I just wrote down what's in the caption.
Oh, yeah.
That's all, the only thing I did. Okay, this is day 2 of notes that we are doing today. Yeah. And if there's stuff that you forget, by the time you get to do day 2 worksheets, there will be a video for you to watch. Again, this is reviewing stuff you've done last year. There's properties of logs that go right off of properties of exponents. I'm going to ask you the exponent property first, and then we'll see how that affects the log property. There is an exponent property called the product of exponent. What's the product rule? If we're multiplying same bases, what do we do to the exponent? You add them. You get x to the 5th. So there's this product rule for logarithms because they are the inverses of exponentials that says if I have a logarithm, base b, and I have a product, we can separate that product, or you can take 2 separate ones and you can make it into a product, but you do it with addition. So I can expand this one to the log base b of m plus log base b of n, and that's because of this rule up here. They're related, they're just inverses. The quotient rule in exponents is like x to the 7 over x to the 4. What would that be? How did you get that? You did x to the, we subtracted, right. So if we have a quotient of what we're taking the log of, we can separate that into separate logarithms by subtraction. You have the same base, separate logarithms, the numerator, subtract log of the denominator. Power rule, I kind of showed you that earlier, but in exponents, if we have like this, there, what do you do with your powers? You multiply them, we would have x to the 12 here. So here we have a product rule that says if I have an exponent, it goes to the front and I multiply it. Which I already showed you kind of right at the beginning of class. And then this change of base rule, I'll show you when we get to that example. But it just allows you to go from base B to any other base that you want. Any other base that you want. Do you know what base you're going to want to go to? Yeah. So where would we maybe use these logarithms? If I need to simplify this without a calculator, I don't want to multiply 9 times 27. It takes too long. What I'm going to do is I'm going to use my property to separate these to separate logarithms. Since these are being multiplied, I'm using the product property, which says you separate the different logarithms by adding. Same bases, you separate that product with addition. So how would that make it easier? What is the log base 3 of 9?
3.
It's going to be 9 is going to become 3 squared. Log base 3 and 3 cancel, we get 2. Remember, what logs do is they just give you the exponent. So for this one here, log base 3 of 3 to the 3rd gives me 3. What is the answer of that big old complicated looking log problem? 5. Here's another one. If I take this and I rewrite it as log base 5 of 5 to the 1/2. Now I'm going to use the property that I used at the very beginning of class. It says this 1/2 goes to the front and multiplies. So now I have 1/2 multiplied by log base 5 of 5. And then these cancel and become 1. So our answer is 1/2. So that's just using those properties. Now a few little more complicated ones. We're going to condense this down to write it as a single logarithm, as simplified as we can. You can work faster than me. I'm going to look at this as 3 separate logs first, then I'm going to condense it down. I'm going to kind of separate this one and simplify what I can. If there's a 1/2 in front, where can I move that 1/2? Because I don't know log base 10 of 9. I don't know that one. But if I move it to the exponent on the 9, and I write log base 9 to the half, what is 9 to the half? 3. Half is the same thing as square root. So now we have log 3. So the middle one, I'm going to do the same thing. I'm going to move that 2 over because I don't know log base 10 of 5. But I'm going to move that 2 over. I'm going to get log of 5 squared. So I have log 25. Same thing here. I'm going to take that 1/3 and I'm going to move it to the 125. So I'm going to have log of 125 to the 1/3, which is the same thing as cube root of 125. You guys are on top of it, 5. So you have minus log 5. And just simplify each of those first. Then we're going to condense it down to 1 logarithm. So right here, if I have addition in between these 2 separate logarithms, I'm going to write it as 1 logarithm. But what do I do to what I'm taking the log of? Multiply 3 times 25. And you guys can write 75. I just, I'm leaving it like that for notes. I will write 75 in a moment. And then when I go to condense these 2 down, the minus means what do we do to this stuff? Divide it. So now I'm going to have log of 3 times 25, which is 75, divided by 5. So we're condensing it down to 1 logarithm. Log 15. And then you could type that in your calculator easily. Log 15. Or maybe we don't need to. Maybe we just need it as log 15. Okay.
Is it always like kind of
No. Not very good. I know both of these do, but
aren't,
no.
but can you put like log these kind of,
We wouldn't. I don't know why they wrote base 10 here, but we don't. Yeah.
If they don't have the same base, don't we not combine?
If they don't have the same base, you couldn't do it. Exactly. These rules always have to do the same base. Just like with exponents, if I tried to do x to the second multiplied by y to the third, I couldn't add the exponents there if they don't have the same base. Okay. Good question. All right. Next one. What do we got here? 2/3 to the 8. I'm going to have log 8 to the 2/3. That one's just like what we were doing in yesterday's assignment, the 2/3. So if you rewrite that as log to the 2 to the 3rd, and then 2/3, what does that become here? So we have log 4. Move that 2 up, I've got log 5 squared, or log 25. So I've simplified my individual terms. Now let's condense it. What am I going to have? Log 100. Is that my final answer? Because what's our base? So if I can rewrite this as log base 10 of 10 to something, I should simplify it. What's my answer going to be? 2. You make it easy.
your worksheet?
Yeah, I'm gonna. So these, I'm just gonna record a separate video for the last 4 examples. You guys are gonna have to watch those last 4 examples.